The graph shows f of x is equal to 4x minus x squared. Draw the graphs and find the algebraic equations of 2 times f of x and 1/4 times f of x. So we'll talk about here stretches which are parallel to the y-axis. We have the graph here of y is equal to f of x, which is 4x minus x squared. So if we write down f of x is equal to 4x minus x squared, then 2 times f of x means we're finding the algebraic equation here will be 2 times all of this, so that'll be 2 times brackets 4x minus x squared, which will give me 8x minus 2x squared. Now if we go to this GeoGebra applet, we can see what actually happens with the graph. The GeoGebra applet I will put in the notes of the video. So here we have the graph of f of y is equal to f of x. Okay, we had to do y is equal to 2f of x, so I'll make that p go to be 2. You can just do that again, you can see what happens. Okay, so we've got 2 times f of x, which is 2 times 4x minus x squared. Okay, what we can see is if we take the maximum point here, this is 4, and then on this one it comes 2 times the distance, which is 4. But it's the same for any other point here. If this point here is 3, then on the image it will be 3 as well. And the same will happen down here as well, but it's a bit more difficult to see. If we take this point here, that's 2, then on the image it will be 4. Okay, so that's what's happening here. So if we just click here, we can see the actual graph. So it's 2 times f of x, which is 8x minus 2x squared. So here is my graph. So we'll take a particular point. That distance there is 4. It's quite easy to do the maximum, obviously, and therefore on the image, which is going to be that point there, that's going to be 2 times 4, which is equal to 8. Okay, so the answer is 8x minus 2x squared, and the blue graph is the graph that you want to draw. So just be careful down here that you do the right thing. So just remember that 4.5, it goes to about roughly there, therefore at 4.5 it will go to twice that distance. That's sort of how it works, so you get these round the right way. So make sure you be very careful when you draw it. Okay, the next case we want to do, when f of x is 4x minus x squared, we want to do a quarter of f of x. That means I need to multiply that by a quarter, so it's a quarter times 4x minus x squared. A quarter times 4 will just give me x, and then minus a quarter of x squared. So just to go to the GeoGebra applet and look what that means. So let's put p back at 1. Okay, so if we go into a quarter, what happens, you can see it's getting smaller. That's 0.25, that's a quarter. So just repeat that. So there it's when p is 1. So if we reduce p to a quarter, the distance therefore now becomes a quarter. So if this was 4, this distance will be a quarter of 4, which is going to be 1. Same sort of thing happens here. You can see that this distance here, it's a bit more difficult to see, but this distance here, let's take this point here. Okay, so this is 5, and therefore a quarter of 5 will be 1.25, which is going to be that point there. So the same sort of thing happens there as well. Okay, so if we just click here, we can get the actual graph. So then we can see the actual graph of a quarter of f of x. These are stretches parallel to the y-axis. So going back to this, here is the graph. So again, taking my same point, it's quite nice to take the maximum point. Okay, that is 4, and therefore this distance here, the image, will move to here. That will be 1/4 of 4, which will give me 0.1. Don't forget the same thing happens down here as well. This is 5. A quarter of 5 is 1.25, so that point will go to there. The same sort of thing over here. Okay, so the answer is x minus a quarter of x squared, and the red graph is the answer there for the second part of the question. Like I say, the GeoGebra applet I'll put in the notes of the video. I hope you've understood, and I thank you very much for watching.